You're from Hyderabad, right?
Yes, sir.
Sure. That means, of course, you know Hindi. In Hyderabad, everyone knows Hindi.
Yes, sir. So should I take the limit as 3 and 0, sir?
So yeah, what?
Should I take the limit as 0?
Limit is 0.
The limit as 0 to 3 or 0 to t?
0 to 3. But t, yeah. For t it should be 0 to 3, fine. And what you will do with that x equals to 1?
I found velocity to be 11, so then
Then
dx by dt is 11.
okay.
Is the answer 34, sir?
Okay, let's check that answer is 34 or not. Okay. So what is given here? A equals to 2t plus 1. So A equals to dv by dt. So dv equals to
A dt.
yeah. So dv equals to 2t plus 1 dt. Integration. So for v, what are limits here?
V 2
vi,
and
yeah. vi and b final. You can say that. Or here already we have as 2 and v final. And time, let's take 0 to t, because time which is given here 3, see that it is time when x equals to 1 meter and u equals to 2. So this condition we have fulfilled, but still we didn't fulfill this condition. So we need to wait for that. So let's keep it as a t. Anyhow, we're substituting t in place of t only, so not a problem. So which is v final minus 2 equals to 2t square, means t square plus t v final equals to t square plus t plus 2. Okay, we finally got how. Even we know for v equals to dx by dt. So dx equals to v dt. So v is what? How much? T square plus t plus 2 dt integrate. So here we can take a limit as what?
0, 1 to x and
Let's take same here, 0 to t. We'll
0 to
substitute t as 3.
yes.
And here x final and x initial. That's what we'll use same way. What we did here, same thing you can do. But even we know that x initially is 1. You can use your same like 1 to x final. That's what they're asking, right? Displacement of the particle, how much it displaced. Okay, so x final minus 1 equals to x cubed by 3 plus x squared by 2 plus, sorry, t squared by 2 plus 2t. So here t equals to 3 seconds. If we write 3 seconds only, no? Are we getting 34? Check.
Sir, can you scroll up a little?
Sure.
Here, how did you get t square plus 2? Sir?
I use this value. I used this t square plus t plus 2. Yeah. And 2 I just send from here. What happened? Any confusion?
I didn't get the integration part, sir. So 2t will become t square and plus 1 will become only plus 1 only, right, sir?
Oh, this one, velocity integration.
Yes, sir. Here we'll get it as t square plus 1 limit of 0 to t.
Yeah. So 2t square by 2 to cancel plus t.
Okay, yeah, we have, yes, sir. Plus t. Yeah.
So forgot the formula n, which will give you x to power n plus 1 by n plus 1. So here this means x to power 0. X to power 0 means 1. Right?
Yes, sir.
So x to power 0 plus 1, which is 0 plus 1, which is x to power 1 by 1.
Does constant not remain the same, sir? No, right?
Yeah. But constant while differentiating, it is 0. While integrating, it's added 1.
Okay, sir.
Okay.
1 second, sir. Let me note it.
Yeah, sure. Then you get me answer also. If I keep t equals to 3, is it getting 34? You got 34, right? Let's check. If it is 34, then
I don't think it's 34. I made a mistake here.
okay, you didn't put this t here. That's what.
Yes, sir.
T cubed by 3 plus t square by 2 plus 2t. That means 3 cubed 27 by 3 means 9. T squared 9 means 3. 27 plus 3. 30 plus 6. Plus 1. Oh, this is divided by 2. 3. 9 by 2. 4.5. 4.5 plus 9. 13. 13 plus 6. 19. 19.5 plus 1 is 20.5. So answer should be 20.5. Check. Okay, go ahead. Done. What happened?
Yes, sir, once again.
Are you stuck somewhere?
No, sir. I'm just floating it up.
अच्छा, ठीक है.
Yes, sir. I got 20.5.
20.5. Now that 20.5 is a displacement, or is it? Or is it 20.5?
It is the displacement.
They're asking find out displacement of the particle. We got here that is x final, that is 20.5 meters.
Oh, yes, sir. So we have to subtract 1 from it.
Exactly. This is x final. We need to subtract by initial. That will be your displacement, which is 19.5 meters. That is your displacement.
Displacement. Got it. You can move on.
Let's go for next concept. We have some few more concepts for 3D, sorry 1D, then 2D will do. These are actually formulas, but I'm giving you as a numerical. So if you learn numerical directly, comes with formula. If I say here, like a type of B, we know U plus T with the formula V S equals to U T plus half.
Half AT square.
Exactly.
V square minus U square is equal to 2S.
And one more formula, which is S nth formula. U plus half A 2n minus nth and nth term. Okay.
Is equal to V plus
So
or U,
U
sir.
plus A by 2
U plus half
A by 2 or half A, whatever. So need now to derive this one, right?
Yes.
Have we derived this one? I think so.
No, sir. For SN.
So Isn't we haven't? Okay. That's good.
No, sir.
So as we know, v equals to ds by dt. So ds equals to v dt, and v we know v u plus at dt. So for time, n minus 1 second. So displacement will be Sn minus 1. Let's assume. This is what we are assuming. So when time is n second, then displacement will be S.
Sn.
Exactly. So if we integrate this term, the previous equation, and substitute Sn, that's it. Done. Integration of ds integration of u plus t, already, right? Here Sn minus 1 and here n minus 1. Sn minus 1 to Sn n minus 1 to integrate this, what you will get? Minus 1, then will be what? Tell me. If you integrate u with respect to dt, what you will get?
U square by 2.
We are integrating u with respect to dt in terms of dt. So there is no t term
Okay,
here.
ut. Ut.
T limits n minus 1. Here at square by 2 limit n minus 1. Here you can keep u outside, doesn't matter. So here Sn minus 1, which is u n minus 1 plus a by 2 n square minus n minus 1 whole square. Okay, let's keep on going. What is this? If I take this here, if I expand this bracket, what will get? N square minus 2n
Square plus 1
plus 1.
minus 2n. Yes.
Yeah. And here n and n will get cancelled. We are left with 1 only. So this will be u plus a by 2 to 2n minus 1. This sign will change, right? Yes. That's what you are getting on this side. Have we made a mistake here? N square minus n square minus 1 plus 2n. Can cancel here and
No,
minus
sir.
n plus 1. So is this correct? 2n minus 1. Yes, correct. So as nth term is un plus un minus 1. Sorry, 2n minus 1. So why we are doing this way? Because Sn, which is equals to Sn minus 1, which is equals to Sn. I mean minus, right? Sn term,
Yes.
which is displacement of nth second. Second only, right? We are starting with second. Okay, very good. Started with second only, yes. And second, right? Okay. Yeah. Any doubt?
No, sir.
Shall we do some numerical?
Yes, sir.
Let's try this one. This kinematics is so big actually. There is 1D motion, 2D motion, force, laws, so many chapters. I taught almost 1 month kinematics for 11th standard JEE class. But it carries all things. 1D we need to learn. Means motion in straight line, then two-dimensional motion. That is projectile motion. Then what else? What next topic here? Yeah. So ray optics, current intensity, and magnetism. Current electricity, electromagnetism. Once you get this exact your syllabus and timetable, just intimate me, okay? Because this 4 topic are big in them itself. So I don't know how much time will take. So according to your topics,
Yes.
I'll teach you that much first.
Yes, sir. But I want you to teach the basics, so it would be helpful for me in that, like a bridge course. Your voice is not audible, sir.
I'm saying I can teach you everything about this topic. It's not a problem. But if your exam comes near and we didn't finish our these 3 chapters also, then it's no use. But I no problem. At least it will be helpful. Whatever you're studying, it will be helpful for your JEE exam. Okay, let's do with this question because these are just I'm going with basic first, then 2D motion. This question number I don't know. Check it. A car starts
13th one.
30. From rest. Accelerates. Accelerates. Uniformly for 20 seconds. To a velocity (72 kilometers per hour). Conversion. Conversion.
Into 18 divided by 5.
18 divided by 5, 5 by 18. See, this way, if you get confused with your answer, just try it. 72,000 divided by 3,600 by 18. So, it's 5 by 18.
Okay, sir.
Is my video lagging? Like, share it. Is my screen lagging?
Your voice is a little lagging at screen. Yes, sir. Little. Voice is barely audible.
Okay. Now is it clear? I think so.
No, sir. I can't hear.
Is it clear now?
No, it's fine.
Okay.
Actually, try turning off noise reduction.
And then all distortion will come out. That's what. Fan voice and all that. This one is okay now. Reduced voice.
Yes, sir. It's okay.
Then all fan sound and all that sound. Okay. So whenever we have this, it then turns at constant velocity. Then finally brought to rest in 200 meters. The constant retardation. Okay, so they are giving retardation. Total distance covered is 600 meters. Okay. So finally brought to rest in 200 meters with a constant retardation. Total distance covered is 600. Okay. Making second values also. Find the acceleration, retardation, and total time. Okay, question nice. Think of it. Try something.
Yes, sir.
I think you should get this. Try it first. They say here a car starts on the rest. So U is 0, that means accelerate uniformly for 20 seconds. So time is 20 seconds. The velocity 72 means 72 into 5 by 18, that is 18 over 72, over 20 meters per second. So with that we can find acceleration.
Yes, sir. Which is 1 meter per second.
I guess so. Time is 20. 0, yeah, correct.
It can translate a constant velocity.
1 meter per second square. Now distance travel in 1 meter per second square acceleration up to 200 meter, right?
Up to 400 meters. I think.
And it runs at a constant velocity and finally brought to rest in 200 meters. So initially 0 half a t square. So t square is 400. 400 divided by 2 is 200. So distance should be 200 meters.
One second.
So that is what I am thinking. While solving what is coming, let's see. Conversion with no, we need what? The total distance covered is 600 meters.
So 200 with an acceleration, 200 with constant velocity, and 200
The
with
retardation.
retardation.
Yes. So total 600. So remaining is 200. Now this total displacement we need because we need to find total time. So total displacement is 600.
600.
So if we find average velocity of this, so we didn't find retardation, no?
Yes, sir.
Retardation here. See, if
Should
it
we
is too,
find the time first?
yeah, but it will be, see, if we think of it, if it is same, right, 200 meters accelerating, 200 meters retarding, that means
Acceleration will
is
equal to
retardation in negative direction. So
negative.
plus 1 and minus 1.
Yes, sir. Yes, sir.
You want me to solve?
I got it, sir.
Will you go for next question?
Yes, sir. So the total time taken is 60 seconds, sir.
60. Let's check for the first. How much it was? T20 given. T is 20. So if we found the distance 200 meters and uniform velocity 20. That's 20 meters per second, right? So 200 by 20, that is 10. And the 20 for accelerating, 20 for retarding, and 10 is for total, like the average. Total 50 seconds, not 60 seconds.
How is the one with constant velocity 10 seconds, sir? Can you solve that part? The time taken by
Let me solve this whole question.
I understood the other part, sir. Can you just do the time taken by car during the constant velocity?
Okay. So first thing, it is given 20 seconds, right? 20 seconds is given.
Yes, sir. 20 seconds, 200 meters, acceleration is 1.
This is 20 meters per second. So here we got 200 meters as our answer, friends. The time, if we take this one as a total distance or distance travel at that time by velocity, which is 20 meter per second, which will give you 10 seconds.
Yes, sir. Got it.
So we got one more. Same that 200 meter for another retarding. So same will be 20 seconds. So 20 plus this 10 plus 20, which is 50 seconds. So if we find for average velocity, we are going to use this AVG velo, which is equals to total displacement 600 divided by 50. 12 is 60, right? Yeah. Average velocity is 12 meters per second.
Yes, sir.
And how we got this second, if you want to see, I can show you here. Like we found like acceleration is -1, right? So if we use that, P equals to U plus AT for, and here it is 0 now. That acceleration will become 0, final will be 0, initial will be that from where it is starting, that is 20.
20.
And this is -1 and T. So T equals to 20 seconds.
Yes, sir. Can you calculate the acceleration for the retardation? Retardation, sir.
Okay, you want this, how to get this -1?
Yes, sir.
So let's see the values. Okay. So for finding acceleration, what we have velocities, we have displacement. Displacement is 200 meters. So V square minus U square equals to, we cannot use this formula because we don't have T also, we don't have A also. 2AS. So we have remaining thing, we don't have A. So we have this one, we have this one, we have this one.
Yes.
0 minus 400, which is 2 into A into 200.
200. Yes, sir. Minus. Got it.
Is this one
Understood.
Do we have time? Yes, we have enough time. We can do one more question. Let's see. Question 14th, right? As you see. Find out distance travel block in 10 seconds for a given situation. Okay. So what they're saying, find out the distance traveled by a block in 10 seconds. My internet gone.
Hello, sir.
Hello?
I couldn't hear you, sir. After you wrote the sentence, your voice got struck.
Yeah, actually, your power cut for a few seconds. So I got disconnected from Wi-Fi. You can hear me now, right?
Yes, sir.
Okay, so this is the condition given. What do you see from the condition?
The force and the velocity and acceleration in different directions.
Initial velocity is different direction, acceleration is different direction. What is it? We need to find distance travel. How will you find this? How will you initiate?
So we'll use acceleration as retardation here, -2.
Okay, give a try. Give a try. Let me connect my laptop charger.
The
Yes.
distance traveled, so we have to find where the velocity is 0. So uh, v minus u by t is equal to a, we have to substitute v is equal to 0.
Okay. Then U will be 10. A will be -2, right?
Minus 10 by x is equal to -2. So the time is 5 seconds where the velocity will be 0. So we need to find the distance in the first 5 seconds and the next 5 seconds. Add those both.
Right? Go on.
So the first 5 seconds, uh, Yes, sir. So distance traveled is 50, but displacement is 0.
Why?
Yes, sir.
Why is it so?
The block in 5 seconds will travel 25 meters and come to rest, and again in the next 5 seconds it'll come back to its initial position.
Yeah, to the traveling or starting point.
Yes, sir.
So it will be 25-meter back, but distance is 50 and displacement is 0. Very good. Correct.
0.
Super. We're learning fast. That's good. There is one more chopper topic. That I think we can do the next class, but let's do some more numerical class. It's related to the topic. Okay. This second topic in the numericals are a little bit so big. We cannot solve it now. But we can do some more thing. That is, I'll give you introduction of motion under gravity, which is three dimension. Three-dimensional motion. We can study that a little bit. We can have introduction. Okay. So
So you're gonna start 2D motion, sir.
yeah, there is one more numerical, like two more numericals for a 1D. That we'll do next class because for that we need one more theory. Theory is a little bit bigger.
Okay. Sir.
I don't want to stop at half. Motion under gravity. That means when the body thrown vertically upward. When the body thrown vertically upward. Okay, so when we are throwing something upward, it includes two-dimensional motion, right?
Yes.
What are two types of motion?
The force we apply and the gravity.
Yes, exactly. So once we are applying force, that means we are giving an object acceleration. And when force acquire maximum velocity or at some point, it will be 0. From that, it starts deaccelerating. It starts coming back, whatever the direction it is. So now it is sometimes it is adding acceleration due to gravity also. Right? Mostly it's happening due to acceleration due to gravity G. Let's occur here. So here in this one, mostly we are going to study about object which is thrown from point A here and back here. So this is some ball here and return back. So at every moment, this acts under gravity. This object acts under gravity. So in this one, deceleration or deaccelerated motion. Second one, accelerated motion. Now, when we are talking about deaccelerated motion, it is because of direction of velocity and acceleration is opposite. So which side it will be? A side or B side?
Toward the B.
Speed decrease. Okay, let me write this one also, then you can reframe your statement again. If you want to. Okay, so deaccelerated motion means the direction of velocity and acceleration is opposite so that speed decrease. So accelerated motion means
the direction of acceleration is in the same direction as gravity.
That means downward direction. And is same. That is downward direction. So speed. Now tell me, it is on side A or side B?
What, sir? I did not get your question.
Okay. So acceleration and deacceleration, which is on side A, which is on side B?
So acceleration is towards the side B and deacceleration towards A.
Exactly, because here we are throwing a ball from here. So direction is opposite to the direction of G. So it is deaccelerated motion. That's why at some point it will deaccelerate. But this one, they both have same direction. Acceleration as well as velocity. They both have same direction. So it will be, at some point, it will be maximum.
Yes.
So when it will be minimum? At the top
At
post.
the peak.
Yeah, at the peak it will be minimum, or let's say 0. Then it will start accelerating in opposite direction.
Yes.
Right? Okay. Any doubt in this acceleration, deaccelerating motion?
No, sir.
Okay. So let's have a class tomorrow, maybe Saturday. Let's see how it works. If other cells are not taking class, then I will take your class.
Okay, sir.
Okay then. See you. Any doubt today?
Thank you, sir. No, sir.
Bye.
Thank you, sir.